So, you decided to play an Uno game with your friends. Everything was fine until you unfortunately drew a lot of cards, ending up with 10 cards in your hand. Well, now you have a whole bunch of them, and you want to sort them out, so you can navigate through them easily in the future. Let's talk about the concept of sorting. Can you, for example, sort a set of fruits, or number plates, or street names of your city? The answer is yes, but to do that, you need to define a relationship between the elements. For example, you can sort fruits by their color, or by size, or by growing time. Each of these sortings is valid, but there are different relations between elements for each of them. The same goes for number plates or street names. You can sort by length, alphabetical order, or numbers in them. Every relation is valid and can exist in the real world. But let's return to our Uno game. We need a relation to sort, so let's invent one. Everyone who ever played Uno knows that there are 4 colors and some different ranks, for example, numbers from 0 to 9 and lots of action cards. However, let's just take 3 of them for simplicity: reverse, skip, and draw plus 2. In the beginning, let's agree that 0 card is smaller than 1 card, 1 card is smaller than 2 card, and so on. That's an easy rule. But what can we say about colors? We can't just say that blue is greater than yellow or green is smaller than red. So, let's define a rule and follow it in the future. Let's suppose that blue is the smallest one, then red, green, and yellow. If the colors of the cards are the same, we should compare their ranks only then. After that, we need to understand what to do with action cards. Again, we should define some kind of relationship, because they are incomparable in usual terms. So, let's suppose that action cards are always greater than number cards, and the relations between them you can see on the screen. Here is a small test for you. On the screen, you see 4 different pairs of cards. For each pair, write in the comments which one is greater. While you do this, let's move forward. Now, when we've defined the relationship between cards, we can sort out our hand of 10 cards. Let's start with the following algorithm. In the beginning, take the second card. Is it smaller than the first one? Yeah, so let's swap them. Note that the first 2 cards are now sorted, so let's move forward. Now, take the third card. Is it smaller than the second one? Yes, so let's swap them. And is it smaller than the first card? No, so let's do nothing. If our answer is no, or we have reached the start of the hand, we should stop moving forward with the current card and switch to the next untouched one. We do the same thing with the 4th, 5th, 6th cards and so on. This algorithm is called insertion sort, and this is one of the most basic sorting algorithms. I don't want to bother you with time complexities in this video. Still, if you are interested, you can see the complete analysis in the article on my Telegram channel. Don't hesitate to join it. I'll post extras, create some activities, and discuss everything with you there. Link in the description. Let's return the cards to the starting point to discuss the next algorithm. Yeah, like that. Now, let's talk about selection sort. The algorithm is simple. Find the smallest card and place it at the beginning. Then, let's do the same thing, ignoring that first one. Then, let's do the same, ignoring the first and second ones. Keep going, and that's it. This is a selection sort. Really, that's it. The next one is the famous bubble sort. Although it's a little bit impractical here, still an interesting one. Let's select the first 2 cards in the hand. If the first one is greater, swap them. Then, take the second and third cards. Again, if the second one is greater, swap them. Do the same till the end. After the first iteration, you will push the greatest card to the end. So, when it's in the end, we can just forget about it and suppose that our hand consists of 9 cards. And after doing the same process 9 times, you will get the sorted hand. And now we are talking seriously. Previous sortings were easy and slow. The next 2 sorting algorithms are more complex but much faster. Let's start with merge sort. First, split our hand into 2 equal or almost equal parts. In this case, we will get 2 parts of 5 cards. Then let's do the same, getting 2 parts of 2 and 3 cards, and then the same before we get exactly 1 card in each part. Now let's go back and merge the cards in the correct order. In the first step, we should compare these 2 cards and place back the smallest one first and then the greater one. Now we have 2 parts with 1 and 2 cards respectively. To merge them initially, we should compare the first cards and place the smallest one at the beginning of the merged part. Now let's do the same with the remaining cards. So we got a merged array. Let's move forward. Let's continue this process and do the same for these 2 cards. Now, we should merge these 2 parts with 2 and 3 cards. Note that each of the parts is sorted. After performing the same steps, we get a new part of 5 cards, which is sorted. Let's quickly do the same for the left side. And now, the last step. We have 2 parts of 5 cards, which we should merge. After performing the same merging algorithm, we will get our 10 cards in hand, which will be fully sorted. Pretty interesting, right? This algorithm is much faster than the previous 3. The last sorting algorithm for today is called quicksort. Why is it called quick? Because it is quick. If it seemed like I said a lot of quick words, it didn't. At least I did it quickly. Let's move forward. Let's randomly pick a card from the hand. Then, iterate over it and place all the cards that are smaller than the initial one on the left and, on the right side, the remaining cards. Can you note something interesting about our initial card? Our picked card is already where it's supposed to be when the hand is sorted. As you may have already understood, we now should do the same for the left and right sides separately. For both sides, again, pick a random pivot, divide the cards into 2 parts and continue. After several steps, you will get your hand sorted. Quick fact: although the name of this sorting is quick, in its worst case, it works with the same speed as the first 3 algorithms. Again, to learn why, the link is in the description. Now you know 5 methods to sort your hand of cards, and this will definitely help you win your next big game. That's all for now. There are a lot of different and interesting sorting algorithms, like heap sort, bucket sort, or radix sort. But this video is already too big for them. Let me know in the comments if you want to learn about them. I hope you enjoyed the video. Please don't forget to like, subscribe, and comment. See you in the next one.